Hello everyone, in this video we will be analyzing the truss using method of sections. We analyzed the same truss before using method of joints. In method of joints, what we did was we calculated the reactions at supports, found the global equilibrium. We selected the joints, each joints, made sure that they only had two unknown forces. Then for each joints we drew the free body diagram, solved for the unknown forces using the equilibrium equations, and carried on. So it was a long step. We have another method called method of sections for truss analysis, and it makes the truss analysis a little bit less tedious than method of joints. In method of sections, what you need to usually do is first we need to find the global equilibrium for sure. Let's just put the reactions that we calculated earlier, 30 kips. Now we need to make sure that we cut down the sections at most the three members in one section. Why? Because once we cut down the section, we're going to apply the equations of equilibrium. We will have one support and then one sub reactions or one support that's in the section. So we will have three equations of equilibrium about that joint or support. That means summation of moment about that point, summation of forces in x direction, and summation of forces in y direction, all to be equal to 0. So if we cut down any section with four members, then we're going to have four unknown forces versus the three equations of equilibrium. So at most, we need to be careful that when cutting down the sections, we need to select at most three sections. Now for this particular example, if we're interested in finding the forces in GH and GC, then we can include both members in a section and cut it down. Let's say this is section 1, and if we cut this and draw our diagram, the left part of the section would be this, and then the right part of the section would be this. Let's consider these unknown forces to be in tension, which is FGH. This cut section is FGC, and then this is FBC. Similarly, at this section, this is FGH in tension, this is FGC in tension, this is FBC in tension. Right, once we have these sections, what we can do, we can either select the left part or either select the right part of the section and then start solving using the equation of equilibrium. In this example, I would like to start from this section here. We have a vertical reaction of 30 kips here. So if you take a moment about point E, the member force FBC is not going to provide any moment about point E. It's going to cancel off. But then GC, the vertical component of GC, and then GH will provide moment at point E. So there will be two unknown forces, and summation of moment about E would be only one equation of equilibrium, so we cannot solve this. But if at point C, if we take a moment about point C equal to 0 and consider counterclockwise positive, then what's going to happen? These two unknown forces are going to cancel out. So we will only have one unknown forces, FGH, which is 6 feet away from this. So this member FGH is providing counterclockwise moment, positive FGH times the moment arm is 6 feet, and the 15 kips, it's not going to provide any moment. This 15 kips is going to provide clockwise moment, 15 kips times 6 feet. Similarly, 7.5 kips is going to provide clockwise moment, so negative. The moment arm is 12 feet. And finally, this 30 kips of reaction is going to provide counterclockwise moment, so positive 30 kips times 12 feet. Summation of all these forces would be 0. If we solve FGH, we're gonna get 30 kips, negative 30 kips, as this would be, negative 30 kips. This means that we assume this to be in tension. This is actually 30 kips in compression. If you remember method of joints, what we had to do, we could not directly go to member GH because there were 1, 2, 3, 4 unknown forces. So we had to start from A, go to F, solve B, find these member forces, and then finally come to G to find the member force of GH. But using method of sections, you can easily do that in one step by just cutting one section. So now if you want to calculate our member force GC, you can do another equation of equilibrium, summation of forces in vertical direction to be 0, considering upward forces to be positive. Then we have 30 kips of upward force, negative 15, 15, 30, 37.5 of downward forces, and the vertical component of FGC. GC, the angle we know this is 45 degrees, so sine 45 degrees, and summation of all these forces in y direction is 0. Upon solving this, we calculate FGC to be 10.61 kips in tension. GH was in compression, so compression again is towards the joint, 30 kips in compression. GC, tension away from joint, which is 10.61 kips tension, right? Again, to calculate the member force GC, we had to first calculate all these member forces and then finally come towards this point, right, for using the method of joints. By using the method of section, you can just cut one section that includes those unknown forces and then use equilibrium equation and simply find the unknown forces.